Okay, I'm going to record the answers to the last few questions that I stopped at question 10. And so let's go through the answers as quickly as I can so the recording doesn't drag on. Okay, so question 11. With question 11, you have your calculator. The easiest way is to go into your calculator and type solve 3x equals 10 negative. Let's just, yeah, you can type that in. You can put that in your calculator because there's a field that you could put the power and put x as your variable and then hit enter. It will give you the answer. So that should not take long. Okay, so use your calculator. Easiest answer for question 11. Let's go to question 12. Question 12. We want the value of t when x is 10. You have to put 10 in here. And so that's just a matter of calculating 90 times 0.98 to the power of 10. So let's see if I've saved myself. I've done this calculation before. If I can find it. Now, again, find the value of t. So we just sort of put that in the calculator and you get 73.53655. It doesn't say how many decimal places, but it's temperature. Temperature, you should say degrees Celsius. So be prepared to lose marks in the exam if you don't say include the units. When time is 27, part B, we've got 27 equals 90.98 to the power of x. Now, look, if this is on the if this is requiring a calculator, it's simply easier just to do the solve and put comma x. That's a lot quicker. Or you could take the 90 across and it is then the log of 27 over 90 to base 0.98. Again, you could still use a calculator to get that. And when you put that in your calculator, you should get 59, about 59.6. Now we're dealing with minutes. Remember, x is minutes, so you need to find the value of x. X includes the unit. Okay, next. The population of a colony of small, interesting insects is modeled by the following. Now, sketch the graph. So, draw your x and y axis. I don't have a ruler, so I'm going to have to try and do this as freehand as possible. And when you find, we want from 0 up to 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay, now for the first 0 to 50, it starts out when t is 0. So when t is 0, 20 times e to the 0.2 times 0 is 20 times e to the power of 0, you should get 20. Up to 50. Now it's positive, and it's going to be sort of doing this. It's exponential. I'll put a 50 in here when t equals 50. And then you can find the position 20 e to the power of 10. 20 e to the power of 0.2 times 50. So a fifth of 50 is 10. So we will say at 50, it's 20 e to the 10. But you have to put that in your calculator to make some sense. And it's 147.78. No, that's not. It's very large. That's not. That's an answer to a. Let's just get this number approximately. And this requires me to go to my calculator on the other computer. So bear with me. Technology. Why does it work when you want it to? Click the icon and nothing happens. All right, so I go main menu, 20 times e to the power of 10. Wow. Okay. 440,529.3 approximately. Let's go up here. And let's start at 20. And let's draw that. It's exponential. Okay, now it's 20 e to the power of 10 between 50 and 70. So it's going to stay at that value. And then after, it's going to reduce. If I was to expand this, 10 e to the 10 plus 70 minus t, 80 minus t. So at 70, that's going to be 10 to the power of 10, 10 e to the 10 plus 10 e to the 10. So it's going to start here at 20 e to the 10. And it's going to go down, this is going to go down to 0. Now, so 10 e to the power of 10 is half of this. So that's like 220. So 20 e to the power of 10 is, when you get the actual number, 264, about 0.7. It's going to level out at that asymptote. See, it levels out halfway. So a lot of people miss that third mark where it levels out halfway. Some people got the first part, they got the second part, but they didn't get the third part for 3 marks. Find n of 10. N of 10 is here, so it's using 20e, using 20e to the power of 0.2 times 10, and this one is about 147.78. Now, put 40 is here. It's again the first one, so it's 20e to the power of 0.2 times 40, and that becomes about 59,619.16. for that one. And 60 is using the middle equation, which is 20e to the power of 10. So it just goes 20e to the power of 10, which, as we worked out before, 440,529.3 for that one. And for 80, we use the next equation, which is 10e to the power of 10 times e to the power of 70 minus 80 plus 1. And you get that answer. And it's about, is this 80? Okay, what's that going to be? Just going to do this in the calculator. 10 a power of negative 10 plus 1. 10e to the power of 10, open brackets, e to the power of negative 10 plus 1, close brackets, and we get about 220, 274.7, close enough. All right, find the number of days that for the population to reach 2968. So we want this to equal 2968. So 2968 equals 20 e to the 0.2t. Now, if you put this in your calculator and use an x, you could simply solve and get the answer very quickly. But if you want to do it a little bit slower, you can do it that way, or you can take the 20 across and then go the natural log, or the log to base e of 2968 over 20 equals 0.2 times x, or in this case t, 0.2 times t. We can take that 0.2 and divide it over here. And then you could put that in your calculator. We get 25 days. And the same applies for this, except instead of 2968, we've got 21932 in that position. So you just replace that with 29132, and you could use, or you could use a calculator and put 21932 in that position, and you'll get 35 days. 35 days. 25 days. Okay. Question 14, 2 questions to go. Show that, okay, here we have to actually do the derivative. So if u is 2x minus 3 and v equals x squared plus 4, you've got your uv. So if y equals u over v, dy dx equals v du minus u dv over v squared. So it's v x squared plus 4 times the derivative of u, which is 2, and then u, so 2x minus 3, times the derivative of v, which is 2x, over v squared. Expand here, we get 2x squared plus 8. Expand here, we get minus 4x squared minus a negative makes plus 6x. And then 2x squared, take away 4x squared is minus 2x squared. I'll put that at the end because plus 6x, put that in the middle because, and there's the 8. And that's done, okay? So you've done that, shown. You can just put as, okay, you've shown it. Find the value of x for which both these derivatives are positive. So, all right, let's do algebra. Where is this positive? Where is this greater than 0? That's always positive because we have a square. And therefore, we want that to be positive. So 2x minus 3 to be greater than 0. 2x is greater than 3. Therefore, x will be greater than 3 over 2. Okay, for that bit. And where is, okay, also because this denominator is squared, that's also always positive. So we want when the numerator is positive. So if we were to sketch this graph and find where it's positive, it's going to be a quadratic because it's a -2. That -2 means it's a sad graph. And if you were to, and I'll just put up here, does it cross the x-axis? And that happens when that equals 0. Divide everything by 2. Plus, you could graphically use your calculator here. You could simply, again, you could just type solve that equals 0, and your calculator will tell you that where it. But I'm just going to change this to be negative, negative, positive, and two numbers that multiply to give -4 and add to give -3. So that's -3, -4 times 1 and -4 plus 1. So -4 and plus 1. So that would be our equation. Now, originally, I could put the negative in front if I work with this. Therefore, x equals 4, x equals -1. So this is 4, this is -1. All right, it's positive between, it's above the x-axis. See, it's above the x-axis between -1 and 4. And this one is, let's make it bright green. There's 1.5, 3 over 2. It's positive after 3 over 2, and so it's so that we get, that's very bright, so that we get a combination of these two. We take both into consideration. Where is x between -1 and 4, and where is x greater than 3 over 2? Well, that'll happen between 3 over 2 and 4. So the answer for part B is therefore x has to be between 1.5 and 4. And that's the only place where they're both positive. Okay. and one more. For the function, we want the derivative to be negative. So let's have a look at this function. All right. I'm just going to go cut out the algebra. I'm just going to look at the graph. The graph is crossing at 0 and at 2/3. 2 minus 2 is 0. It's going to be a sad graph for the same reason as I mentioned before. That's a negative 12. So it's a sad graph. That means it has a maximum. So it's going to come up like this. It's going to 10. And it's a parabola. So if that's 0, that's 2/3. This is 1/3. So where is the gradient? The derivative is the gradient. Negative. That means it's coming down. And so you can see it's going to be to the right of the turning point. Therefore, the answer is when x is greater than 1/3, it's got a negative slope here. Okay, after 1/3, so x is greater than 1/3 is this graph A. All right, that's it. I hope this has helped. Stay happy. Just got to find where to turn it off. All right, until we talk again. I can't turn it off. Yay.